Alright, it's my goal in this video to get you started on the wonderful world of VPython programming. So to do that, what we're going to do is we're going to use the starter code that I made for you. And I'm going to just take you through it so that you have an idea of how to use it. Once you get comfortable using just the starter code that I made for you, you can start to add some embellishments and we can do some simulations and some experiments with it. And I think you're going to be hopefully at least a little bit excited about how easy it is to use and also how many different things that you can do with it. So I'm not going to take you through everything. This stuff you just leave alone. These are things that you're going to need. I'll tell you about them briefly. This is for spreadsheets. This is something that makes it so that you can do physicsy stuff easier. This is what makes the pretty pictures that you're going to see. And I really don't know what this is, but apparently it's important. So we're just going to leave it there. Eventually I'll figure out what that does. This part you can see is where we're going to initialize the different graphical aspects of this. So the first thing you do is you make a graph. These things here, these just change the sizes, that type of a thing. The scene, now this is something that you might need to modify from time to time. This gives you the width and the height of the screen. You can certainly make those larger, and in fact I'm probably going to make, well, I probably won't actually, but you can make them larger. The background, you can change colors. The range is something that you're probably going to change fairly frequently. And this gives you the ability to make it so that you're zoomed in more to start with or you're zoomed out more to start with. And it's kind of a nice thing to have there. This is the title. And if I were to scroll over, you can see it just says Python test. It's pretty boring. We can change that if we want to, but I'm not going to bother right now. Now we need to create some objects, and because we're going to do this sort of modified Coulomb's law experiment, we need two objects. So I'm going to call those ball and ball2. Very creative. And this is just invoking the fact that we're going to make spheres to match the name ball. And we have colors that we can give them, different colors because they're different objects, and this radius just tells us the size that the balls are going to have. The trail is just going to track the motion. This is just going to set the origin of the screen, and this is going to make an arrow. And I had an arrow too, but I didn't need it, so we'll use that maybe later. Arrow 1 though is just going to be an arrow, and it's going to be located on the ball, on its position. That's what this ball.pos stands for. This is the position of the ball. So we're going to start the position of the arrow where the ball is, and we're going to have it aligned really nowhere to start with. We'll take care of that later, and we'll make it yellow because we've got blue, red, and we just want to fill out the rest of the primary colors with some yellow. Now what I'm going to do is I'm going to initialize the conditions, the properties of my system. So I have the ball, which is going to be our primary focus, and it has a .m, which stands for the mass, and it's going to be pretty small, about 50 grams, and we're going to give it a charge, which I'm going to say ball.q, and that's 2 times 10 to the negative 6th. And the fun thing about this is that the program really doesn't know what this .m or .q means. I just put them in there, and it doesn't have any particular system that it makes use of them with or anything like that. It's something that I build into them just by doing a .q. So we'll have to take care of what that .q does later. And now I have ball2, and I really didn't need to do anything with ball2 because in this situation, ball2 is not going to do anything. We're going to assume that ball2 is just completely fixed in space and can't move. I gave it a supermassive mass. It's basically like a car next to like a little ball, and it's not going to go anywhere, even if we let it. And here is k. K is a proportionality constant for Coulomb's law, and it's 9 times 10 to the 9th, which is huge. That's why we get away with having such small charges, and we'll still see an effect. This part here is just initializing the positions and velocities at the very beginning of the simulation. So we have initial position and velocity of the ball and initial position and velocity of the second ball. And the only thing that's not at the origin is I put the second ball a little bit off to the left of the screen, negative 0.25. This, I should say here, these three numbers here, this is x, y, and z. So I could actually write, if I have, oops, that didn't work out. That's not working out at all. Let me just erase this and we'll move on. I'll figure out how that tool works a little bit later. So anyway, we have x, y, z. That's what they mean. So this is just in the x direction, but it's still on the origin in the y direction and z direction. And I set the initial time equal to 0. Now we start to get into the interesting stuff. This is my time frame, or my steps in time. And this is something that we looked at a little bit last year when we did some simulations, and this is just 0.005 seconds. This part here is a little bit odd, right? Looks a little bit codey. You don't need to do anything with it, which is nice, except for maybe change this name, and I'm going to do that now. I'm going to call it simple C for simple Coulombs law. And you can make different names for it. What it'll do is it'll actually overwrite this file over and over again if you don't change the name of it. Also, it will hate you and shut down if you leave this file open when you try to run Python. So make sure you close this file down or rename it each time. Both have their pros and cons. So we don't really need to do too much else. I'm going to add in another, here we'll call this force, and I'll do that in newtons. So all I'm doing here is I'm giving column headings. That's all that this says here. And eventually what I'll probably do is add a velocity heading as well. So what we're going to do, this is called the calculation loop. This is where we actually predict and visualize the motion that the charge is going to have. And this is going to be at t less than 1. So this loop will run a lot of times, actually, because it's only going to advance by 5/1000ths of a second, and it's going to do that for 1 second. This is where we identify the force. There's only one force involved, so it's pretty straightforward, hopefully. I've got my k constant, which is what I'm going to multiply everything by, and hopefully by now you know that to calculate the Coulomb force we need to take the charge of the balls, multiply them together, and divide them by the distance between their positions squared. That's the idea here. So we're taking ball 2's position in the x direction, that's what that stands for, its position in the x, and the other ball's position in the x, and we subtract them. This part right here, this is all within one parenthesis if you look carefully. We have two parentheses here, we close the one off, we close the second one off here. So this power function just says take this quantity and raise it to this power here, which is a 2, meaning squared. And this is all in the x direction. All that I've done here is I've made a new vector which has an x, a y, and a z. And we have nothing happening in the y and z direction because everything is on the origin in the y and z direction. Next we'll predict the velocity of the ball. And hopefully this is not completely unfamiliar because you watched that Strange Guys video. And so we take the ball's velocity, and it's going to be equal to its previous velocity. So this is the new ball velocity equals the previous ball velocity, plus this is the acceleration times the change in time, right? Force divided by mass is acceleration times the change in time. Gives me the change in velocity. So that's all that this statement is saying. Ball velocity new, ball velocity old, plus how much it's changed since it was the old value, which is a pretty simple idea. And the same thing is true for the ball's position, and we also update the time. This stuff down here is just adding in trails so that we can see the motion and giving us a plot of the position versus time of the ball. And we could certainly do different things as well, and we probably should, just so that we're sure that we know what we're doing. Now this part here is a little bit interesting. This is where we identify what's going to happen to the arrow that we initially were going to draw. And the arrow scale is something that you can try to solve calculation-wise, but you can also do some trial and error. 10 is going to work out well for us. You can experiment and see what it looks like when you go to different values. And then you'll have to change that periodically. And my first arrow is just going to be its position. It's going to be wherever the position of the ball is. So it's going to be coming from the center of the ball. And it's this arrow dot axis is really just indicating how big is the arrow going to be. And we're going to just take the net force. So this arrow is going to represent the force that's acting on the ball. And that's about it for the most part. This rate, if it's running too slow for you, can make that number bigger. And this part here is letting us know what we want outputted to the Excel file. So I don't want to go too much longer, but what I'm going to do is I'm just going to run this program, so that you can see what it looks like. So I go up here to run, and I run the module, and hopefully I don't get errors, right? And we can see here that it builds a graph as time goes by, and it also shows us what happens to the ball as time goes by. So we get to see these two things in real life, and you shouldn't even have to change the code at all to get the results that I just got. Whoops. Now, one of the nice things about VPython is that you can actually just go in and so it's a little bit better. You can actually just go in and click, and you can get a feel for where the points are. But we did export it to Excel, so we don't need to guess. One of the things that you can see here, though, is that it does seem to flatten out. The slope doesn't seem to be getting very much larger as time goes by. And one of the things that we can do, if I run this again, I'm going to focus on this part right here. So you can see that was the force arrow, and it was massive to start with because they were very close together. And then as it gets further and further away, you can see that that force arrow gets much, much smaller. So it's having less impact on the motion of the object, which explains why it's not continuing to speed up at the same rate that it was initially. The last thing that I'm going to do here is I'm just going to show you where you should install your files, or how you should arrange your files so that you're always able to access what you need from them. Alright, so what I did here was I went into my Python 22.7, it comes up as Python 27 folder, and I went into the library folder, the capital L IB folder, and then I made a new folder called AP Physics Summer, and I put in this Phys Utility feature. And this is one of the things that you need to download in order for all of this to run correctly. And any file that you make in this class, whether over the summer or during the school year, if we do some more things with VPython, you're always going to need to make sure that these files are in the same folder as the file that you want to run. Otherwise, it won't run properly. So that's something that you're going to have to make sure of. I'm just going to do all of my files in my AP Summer Physics, or AP Physics Summer file folder, so that I'm sure that I have these present. And we're not going to use so many codes that it's going to become cumbersome. So hopefully that gives you an idea of where to put the files, and also a quick rundown of how the file works. In the next video segment, what I'm going to do is I'm going to take you through the Excel spreadsheet so you can see how that looks, and also some of the things that you can vary so that you can get some information that might be useful for you to get a better feel for how this works.